Welcome all. Today we are going to discuss is about the module 1 fundamentals of logic. So the fundamentals is nothing but the basics of logic. Logic is nothing but method of reasoning. Reasoning can be any ways. It can be a statements or sign language or a symbolic language. And here in this particular subject we are going to express our logic in terms of symbolic language. That is why we call it as mathematical logic. So here we go, the introduction goes on like this. Logic is method of reasoning. Logic is expressed in a symbolic language is called mathematical logic. So what is proposition? Proposition is nothing but it is a statement, declaration statement which in a given context can be said to be either true or false, but not both. So, any statement, any person can give any statement, and those statements can is called as proposition. It is need not to be truth only always. It can be false as well, but a single statement at a time it cannot be true as well as false. It should be either true or it should be either false. So the best example for proposition is Bangalore is in Karnataka. First thing there is it is a statement. So if it is a declarative statement, then what we call it as? We call that as proposition. Second thing what we have to check is whether it is a true proposition or false proposition. So as we know that Bangalore is in Karnataka, it is a true proposition. The next thing is second statement is 7 is divisible by 3. First thing is it is a statement, therefore it is a proposition. Secondly, we should check whether 7 is divisible by 3. No, it is not divisible by 3. So it is not a true proposition, meaning it is a false proposition. Xy is equal to yx. In this case, if the value of x and y is provided, we can tell whether it is a true proposition or false proposition. However, here we don't know the values of x and y. Therefore, we cannot say whether it is true proposition or false proposition as we don't know the value of the x and y. That is what here is given in the notes. For this, we cannot decisively say whether it is true or not unless we know that what is x and y. Suppose if the x and y value is provided, the case is different. At that point of time, I will substitute with x and y, then we can come to the conclusion whether it is true proposition or false proposition. Here at present, we don't have the value of x and y, therefore, we cannot conclude it as a proposition. As per our definition, it can be either true or false, but not both. So, this cannot be a proposition. Propositions are usually represented by small letters. From A to Z, any letters you can take and represent. Generally, we will start with P, Q, R, S, and so on. The truth or falsity of proposition is called as truth value. Truth value is nothing but value of that particular proposition or a statement. It can be either true or it can be false, but not both. If it is true, we will represent it as 1, and if it is false, we will represent it as 0. If a proposition is true, it is denoted by the truth value 1, and If a proposition is false, it is denoted by the truth value 0. Logical connectivities. So we know that we have a statement and that statement is called as a proposition, right? All times we cannot have the or simple proposition. In case if I have to combine more proposition, then in such cases we will use logical connectives. What are logical connectives? We can use not, and, if then, if and only if. Such words are called as logical connectives. Logical connectives are nothing but these are the connectives that helps to join or combine the two or more simple propositions. Now let us see what is a compound proposition. The new proposition is obtained by combining the two given proposition using the logical connectives or called as compound proposition. Before, in examples of propositions whatever we have seen, that those are simple propositions. So simple propositions, if we are combining using these logical connectives like not, and, if then, if and only if at all, we call it as compound proposition. So what is a simple proposition? Proposition which do not contain any logical connectives are called simple proposition. Why it will not contain any logical connectives? Because already it is a single statement. So one single statement will not have any connectives. The statement itself will tell you the meaning. Next thing we have is called as negation. Negation, we represent it with this symbol, tilde symbol. We represent it with a tilde symbol. A proposition, when we call it as negation, is obtained by inserting the word not in an appropriate place, is called negation of the given proposition. So any statement which contains not, that is nothing but negation. Okay, the negation of a proposition P is denoted by tilde of P. This you can read it as not P, because we are going to use the logic connective word that is nothing but not. Negation is nothing but not. Not means, in simple words, I can say that whatever the statement is given, opposite of that will be your negation. For example, he is a boy. What will be the negation of this statement? He is not a boy. So when the word, if you are inserting with the not, then that will become a negation. Let us see the example. And the best example we can give is, as we are aware that the propositions are represented with the small letters, here we are representing with the small letter P. 3 is a prime number. P is a 3 is a prime number. So what will be the negation of P? It is nothing but 3 is not a prime number. Just inserting a not in the given proposition in an appropriate place, we will get the negation statement. 3 is a prime number. Is it true? Yes. So the value will be 1. 3 is not a prime number. That is a wrong proposition, false proposition, and false proposition we denote it by 0. So we have to write a truth table for this P and negation P. If your P is 1, if it is true, the opposite of that negation P will be 0. If your P is 0, opposition negation of P will be 1. Okay. In short, we can say that opposite of that. 1 means P is 1 means negation P will be 0. P is 0 means negation of P will be 1. Second example, P 8 is divisible by 3. This is a proposition denoted by P, small letter p. And what will be the negation of p? 8 is divisible by 3 means negation of p will be 8 is not divisible by 3. For the given statement, we are inserting not. That's it. So now let us check what is the truth value of this proposition. 8 is divisible by 3. No, it is not divisible by 3. So it is a false proposition. False proposition we denote it by 0. So the p's truth value is 0. Negation p. 8 is not divisible by 3. Yes, it is not divisible by 3. Therefore, the truth value of negation p is 1. Now let us see the truth table for this. P negation p. If p is 0, negation of p will be 1. If p is 1, negation of p will be 0. That is all about the negation. Now let us discuss about called as conjunction. What is conjunction? Conjunction is denoted by this caret symbol. This caret symbol meaning it is a conjunction. We can call it this conjunction means and. You have to read it as and wherever you see this symbol. Now let us go with the definition. A compound proposition is denoted by inserting the word and between two given proposition is called conjunction of the given proposition. The conjunction of P and Q is denoted by P and Q. This symbol, no need to write A and D, and as we are going to represent in symbolic form, you have to use this caret symbol. Okay, P and Q. The conjunction of P and Q is true only when both P and Q are true. In all other case, it is false. In all other case, it is false. Meaning your p value as well as q value should be true. Conjunction will work like a multiplication. For our understanding, you can remember as conjunction is nothing but a multiplication. So anything multiplied with 0 will give you the 0 value. Right? Now let us see the truth table for the better understanding. P, Q. See, we have to take it as 0, 0, 0, 1, 1, 0, 1, 1. If P is 0 and Q is 0, P and Q will be 0. P is 0, Q is 1, P and Q is 0. 1 is 0, P is 1, Q is 0, P and Q is 0. P is 1, Q is 1, P and Q is 1. In our understanding, let us try in a multiplication way. 0 into 0 is 0. 0 into 1 is 0. 1 into 0 is 0. 1 into 1 is 1. So anywhere you see the and for conjunction, you can remember it as multiplication. Okay, 1 into 1 is only 1. All other cases you will get 0 itself. Now let us see the next one, that is nothing but disjunction. Disjunction is it works like a addition. For our understanding, we can say it as it works like a addition. So let us see the statement. A compound proposition is obtained by inserting the word or between the given proposition is called disjunction of the given proposition. Okay, anywhere you use the logical connectivities or, then we call it as a disjunctive statement or a proposition. So the disjunction of P and Q is then denoted by P with this symbol Q. Okay, so while reading how it can be read as, it has to be read as P or Q. As I told you that it will work like a addition. Let us see the truth table for the better understanding. So all the cases you have to take P, Q, P or Q. 0 0 0 1 1 0 1 1. 0 0 will give you 0. 0 plus 1 will give you 1. 1 0 will give 1. 1 1 also will give you 1. It is not that you're going to do the basic addition. Okay. When both the values of P and Q are true, then only your disjunction of P and Q will be true. Else, no. I mean, when both the statements are false, then only your disjunction statement will be false. In all other cases, it will be true. The disjunction P or Q is false only when both P and Q are false. Otherwise, it is true. In all other cases, it is true. Okay, for our understanding, you can take it as addition. Okay, conjunction will work like a multiplication, disjunction will work like a addition. Now let us go for the next one, that is nothing but your exclusive disjunction. Disjunction means what? Or right? Exclusive disjunction. Exclusive disjunction is represented with this symbol. Disjunction symbol, along with that, under that we have to put a small hyphen kind of a thing. The exclusive disjunction of two propositions P and Q is denoted by, you have to read it as either P or Q. Either P or Q is called as exclusive disjunction. Very simple. If it is disjunction, we will read it as P or Q. If it is exclusive disjunction, can be read as either P or Q. Okay. The exclusive disjunction is true only when either P is true or Q is true, but not both. Any one should be true. Both are true, it will not agree. And both are false, it will not agree. Okay. So if P is 0, Q is 0, either P or Q is 0. P exclusive Q is 0. 0 P is 0, Q is 1. P exclusive Q is 1. P is 1, Q is 0. P exclusive disjunction is 1. P is 1, Q is 1. P exclusive Q is 0. Why? Because both cannot be true or both cannot be false. Now let us discuss another concept called as conditional. What is conditional? Conditional is represented with this symbol, arrow, arrow symbol. A compound proposition is obtained by inserting the word if then. If then in an appropriate place is called conditional. It is a condition, right? If I am telling if you attend the class, then only you will get marks. So it condition is applied here. So any conditional statements, if you are seeing if then that is called as conditional. The conditional of P and Q is denoted by P conditional Q, or you can read it as if P then Q. If P happens, then only Q will occur. Meaning it means that same. Next thing is the conditional P, if P then Q is false only when P is true and Q is false. So if your P is 1 and Q is 0, then only your conditional will go false. In all other cases, it is 0. So now let us see this one. The truth table of P, if P then Q. So it is P is 0, Q is 0, it is 1. Only thing is if P is 1 and Q is 0, P or if P then Q will be 0. 0, 1 will give 1. If P is 1, Q is 1. P conditional Q will give 1. In short, how to remember this? You can remember it as 100. If P is 1, Q is 0, answer will be 0. See, 1, 0, 0. All other cases it is 1. And now let us discuss about biconditional when we call it as a biconditional. Biconditional is represented with the arrow mark directing right and left with this symbol. A compound proposition is obtained by inserting the word if and only if in an appropriate place is called as biconditional of the given proposition. If and only if, very particular. And one more way of representing biconditional is you can say as IFF, that also represents the biconditional statements only. So it is denoted by P, this arrows, this symbol, biconditional symbol Q. The biconditional PQ is true only when both P and Q have the same truth values, otherwise it is false. By means true. Both should give the same values. Then only the answer will be true. If P is 0, Q also should be 0. Then the answer will be 1. If P is 1, Q should also be 1. Then only the answer will be 1. Else it will give you the 0. So now let us see the truth table and get into the conclusion. See, PQ, if P is also same, Q is also same, then only the answer is 1. 0, 0 will give you 1. 0, 1, it is not matching, so it is 0. 1, 0, it is not same, so it will give you 0. P is 1, Q is 1, the answer is 1 because both are same. P and Q biconditional is also equivalent to P is implying to Q and Q is implying to P. But that is what this both the way it is true, right? So P conditional Q and Q conditional P. That is what the meaning. So you can represent it in this way as well. Combined truth table. Now let us see the combined truth table of all the whatever the logical connectives we have seen. Let us check for that. Okay. So as we know, generally we will have the four values. We will check for the four values. It is 0, 0, 0, 1, 1, 0, 1, 1. Okay. So negation of P. Negation of P is nothing but if P is 0, negation of P will be 1. P is 0, negation of P is 1. P is 1, negation of P is 0. P is 1, negation of P is 0. Q. So negation of Q, same thing. If here it is 0, answer will be 1. If it is 1, the answer will be 0. 0 means 1. 1 will give you 0. P conjunction Q. P conjunction Q works like a multiplication. Now let us check. 0, 0 will give you 0. 0, 1 will give you 0. 1, 0 will give 0. 1, 1 will give you 1. P disjunction Q. P disjunction Q is nothing but 0, 0 means will give you 0, 0 or 1. It will give you 1. It works like addition, right? So 1 plus 0, it will give you like 1, 1, 1. Then also it will give you 1. Either one of the values true, it will say it is true. P exclusive disjunction Q. P exclusive disjunction Q when they are opposite. I mean when both P and Q are opposite in the having the opposite values, then only it will give you 1. Okay. So now let us check. 0, 0 will give you 0. 0, 1 will give you 1. 1, 0 will give 1. 1, 1 will give you 0. Same thing should not be there. It will not agree. So P conditional Q. P conditional Q, read it as if P then Q. Right? For this we have to remember it as if P is 1 and Q is 0, then it is 0. In all other condition, it will be 1. As I have told you, remember it as 100. P is 1, Q is 0, then it will give you 0. So P 0 0 will give you 1, 0 1 will give you 1, 1 0 will give you 0, 1 1 will give you 1. Biconditional Q, if both the values are same, then only it will give you 1. So PQ is 0 0 will be 1, PQ 1 1 will be 1. On other cases it is 0. Q implies P. If Q, then P. So let us check for that. Q and P. Now our first proposition is Q, then the second proposition is P. So you have to check like this: 0 0, Q is 0, P is 0, it will give you 1. Q is 1, P is 0. So it is 1 0. 1 0 will give you 0. 0 1 will give you 1. 1 1 will give you 1. So this heading part is important. So what is implying? That is highly important. If it is P implies Q, the value would be different. If it is Q implies P, that value is different. So be careful while writing the truth table. Now let us discuss the problems in next class. Thank you.